Good morning and welcome to our talk on measles virus reemergence. My name is Christian Rosenow and I'm joined by my colleagues
Kirstin
and John Young.
So to start with a little bit of background information on measles virus, it, like rubella virus and mumps virus, is a member of the family Paramyxoviridae. Measles virus is specifically a member of the genus Morbillivirus. These viruses are enveloped with a negative strand RNA genome. The measles virus genome contains 6 genes. mRNAs are produced by the L protein and RNA-dependent RNA polymerase. These mRNAs are produced in sequence as the polymerase moves from 3' to 5' termini of the genome. However, termination of synthesis must occur before the next mRNA can be synthesized. The L protein may dissociate from the genome, but if that's the case, it must reassociate at the 3' terminus of the genome, leading to greater production of 3' genes. These events all occur in the cytoplasm of the infected cell.
Measles virus pathogenesis begins with transmission. This can occur through airborne virus particles, which can stay alive in the air for up to 2 hours, or via direct contact. Primary infection of the respiratory epithelium gives way to primary viremia and secondary infection in the lymphatics, central nervous system, conjunctivae, and the urinary tract. The rash characteristics of measles results from T cells targeting cells of the capillary endothelium. The earliest sign of measles infections, occurring 10 to 12 days after exposure, is a fever. White spots in the mouth, called Koplik spots, are used as diagnostic signals 2 to 4 days prior to rash formation. Rashes typically spread for 3 days before fading away. The incidence of infection and symptoms is highest in children.
We'll move into the mechanism of measles virus's reemergence in the Western world. In 2016, the World Health Organization declared measles eliminated from the region of the Americas, that region including North America, South America, and the Caribbean. Despite this classification, full eradication has not occurred, and outbreaks continue to occur, including separate incidents in 2011 and 2015, in which greater than 150 cases were confirmed in each of the 2 outbreaks in the United States. In 2012, over 30,000 measles cases were confirmed across the continent of Europe. Compounding the issue of measles spread is the rise of globalization and international travel, potentially importing the virus from endemic regions. In addition to the high transmissibility of measles virus, with an R0 value, a measure of transmissibility, of 9 to 18. For perspective, the R0 of smallpox is estimated to be between 5 and 7. This high transmissibility is significant, as it means that population immunity must be nearly 95% in order to protect susceptible individuals.
As mentioned, measles is a highly transmissible virus. Therefore, development of the disease, even after vaccination, decreased immunity to the measles virus over time, lax in vaccination, and other factors can all be detrimental. The measles vaccine, MMR, has an approximate 2 to 10% failure rate, meaning that 2 to 10% people vaccinated failed to develop protective antibodies and have the potential to become infected, which is why reaching the 95% of the population being vaccinated threshold is vital. Furthermore, between 1989 and 1990, 20 to 40% of the measles cases in the U.S. had been vaccinated, and in 2011, over 50% of the 98 cases in Canada had been vaccinated. Having individuals vaccinated develop measles leads to questions about why the vaccine is not protecting them against the virus. Some studies have shown that immunity to the virus decreases over time. Lax in vaccination, however, is the leading cause of the recent outbreaks of measles. Misperceptions into the harmful side effects of the vaccine, as well as the seriousness and existence of measles by some members of society, led to delayed vaccination and left individuals more susceptible to disease. Underreporting of measles cases has also contributed to the misperceptions and increased concerns for public health. Travel to and from regions where measles virus is circulating and vaccine is not widely available, and then is brought back to regions where the virus is uncommon, can also contribute to outbreaks. Outbreaks are have been correlated to follow the rainy season in the tropical climates and late winter and early spring in temperate climates. Underdeveloped nations experience a higher prevalence of measles cases because they do not have access to the vaccination developed countries have. However, they are not the only individuals at risk of developing measles, as developed countries are experiencing more and more outbreaks each year.
In conclusion, among diseases that are preventable with vaccines, measles has one of the highest death rates in young children. This is due to its high transmission rate and the loss of herd immunity, as over 95% of the population needs to be vaccinated to prevent outbreaks. Lastly, these outbreaks are related to misinformed parents that are either delayed or choose to not vaccinate their children, failure of the vaccine to produce immunity, and travel of infected individuals to and from endemic regions.
Thank you for your time this morning and your consideration. We appreciate it, and we'll open the floor to questions.